Hi, welcome to a solution video of the International A-Level Pure Mathematics P2 that took place in January 2021. Here is part 2, which is the last part of this paper. Let's get started. Problem 6. Show that the equation 3 sine theta cos theta divided by 2 sine theta minus 1 equals to 5 tan theta when sine theta is not 1/2. And this equation can be written in this form: 3 sine cube theta plus 10 sine square theta minus 8 sine theta equals 0. And then we have to solve the equation when x is from negative pi over 4 to pi over 4, this equation. And we have to give the answer to 3 decimal places. To rearrange from this equation to this equation, we have to change all the trigonometric terms to be sine. 5 tan theta, we change it to sine theta over cos theta. After that, we move cos theta to the left-hand side and then we move this whole term to multiply the right-hand side. So this one will be 3 sine theta cos theta times cos theta here, 5 sine theta, 2 sine theta minus 1. And we expand this term into each term inside the brackets here. So the answer will be 10 sine squared theta minus 5 sine theta. And for the left-hand side, we have 3 sine theta cos squared theta. We can change this one to be sine theta from cos squared theta plus sine squared theta equals to 1. From this identity, we can see that cos squared theta equals to 1 minus sine squared theta. So it will be 3 sine theta times 1 minus sine squared theta. And we will have 3 sine theta minus 3 sine cube theta. And then we move all the terms in the left-hand side to the right-hand side. So it will be 3 sine cube theta plus 10 sine squared theta minus 8 sine theta equals to 0, which is the same as this one. So here is the answer. In problem B, we have to solve this equation, and from the previous equation, we know that this equation can be changed to this one. And you can see that these two equations are similar. We just change from theta to be 2x. So that means this equation can be written in this form too. So we can rearrange this equation into this form, which is 3 sine cubed of 2x plus 10 sine squared 2x minus 8 sine 2x equals to 0. To solve this equation, we have to factorize sine 2x. So sine 2x, this one will be sine squared of 2x plus 10 sine 2x minus 8 equals 0. Then we can factorize this term. So sine 2x, this one will be sine 3 sine 2x minus 2 times sine 2x plus 4 equals to 0. So from here, we have these three terms multiply each other and get to 0. That means either of them has to be 0. Sine 2x equals to 0, or 3 sine 2x minus 2 equals to 0, or sine 2x plus 4 equals to 0. In this problem, x varies from negative pi over 4 to pi over 4. But then we have double angle here, so we have to make this range to be the range of double angle. To change it to double angles, we can just multiply 2 at each term here. So the new range will be negative pi over 2 less than 2x less than pi over 2. Consider from a unit circle. We can start from negative pi over 2, which is this one, to pi over 2. This is the path. Let's consider the first equation. We have sine 2x equals 0. So when sine is 0, that means sine is at 0 or at pi. But since pi is not in this range, so then we can just answer only 0. That means 2x has to be 0 in order to make sine 2x to be 0. So x is 0. Here's come to another case. We've got 3 sine 2x minus 2 equals 0. So we can solve for sine 2x first. Sine 2x will be 2 over 3. That means 2x is the arcsine of 2 over 3, which is 0.73. That's a 2x. If we try to locate 0.73, 0.73 is right here, and sign in this case has to be positive, so the answer can stay in the first quadrant. So in this equation, 0.73 is the only answer. So then we can solve for x. X is 0.73 divided by 2, which is 0.365, which is also in between negative pi over 4 to pi over 4. And for the last equation, we've got sine 2x plus 4 equals to 0. So that means sine 2x is negative 4. And if we consider the range of sine 2x or sine x, the range of sine 2x is in between negative 1 to 1, same as the range of sine x. And you can see that negative 4 is out of this range. That means this equation has no solutions. Hence, the answers are x equals 0 and 0.365. Here's problem 7. Solar panels are installed on the roof of a building. The power P produced on a particular day can be modeled by this equation, where T is between 8.5 and 15.2, and T is the time in hours after midnight. The graph of P against T is shown in figure 1, which is this one. A table of values of T and P is shown below, with the values of P given in 4 significant figures where appropriate here. And in problem A, we have to use the given equation to complete the table, giving the values of P to 4 significant figures where appropriate. So in this part, we just have to substitute the given values of T into this equation. So for the first one, T is 10. So we substitute 10 into this equation. It will be P equals to 0.95 plus 2 to the power of 10 minus 12 plus 2 to the power of 12 minus 10 minus 10 minus 12 squared. And the answer is 1.2. Now we put 1.2 here, and for when t equals to 11.5, we input 11.5 into this equation, and the answer is 2.821 for 4 significant figures, and this is the answer of the first part. The amount of energy in kilowatt hour produced between 10 and 12 can be found by calculating the area of region R in this shaded region. In part B, we have to use trapezium rule without the values of P to find the estimate for the amount of energy produced between 10 to 12. Give you answer to 2 decimal places. And you can see that these data are corresponding to the data from the previous table. So we are going to use the information in this table to find the area. And according to the trapezoidal rule, we know that the area equals to h over 2 times f of the first point, which is f10, plus the function of the last point, which is f12, plus 2 times the function of the points in between. So this one, it will be 2 times f10.5 plus f11 plus f11.5. H represents the step between the two values of t. You can see that from here to here, it is 0.5, also 0.5 here. So that means H is 0.5. So we can just put 0.5 here over 2 F0, which is 1.2, plus 2.95 plus 2 times 1.882 plus 2.45 plus 2.821. So that means the area will be around 4.61 for 2 decimal places. And you can see that the area represents the amount of energy in this case. So you can just use this one as energy. So the energy is 4.61. That's the answer. Problem 8. A sequence A1, A2, A3 is defined by this relation. An plus 1 equals to 2 times an plus 3 squared minus 7, where a1 is p minus 3. P is a constant. In the first part, we have to find the expression for a1 in terms of p, and we have to give the answer in the simplest form. For the second part, the summation of an where n equals to 1 to 3 equals to p plus 15, and we have to find the possible values of a2. So in problem A, to find a2, we can find a2 from this formula. a2 will be 2 times an, which is a1, plus 3 squared minus 7. And since a1 is p minus 3, so we can plug in p minus 3 here, and then plus 3 squared minus 7, which is 2p squared minus 7. And here is a2. In problem B, we have to find the possible values of a2 with this information. So first we write down the information of summation n equals to 1 to 3 of an. This one will be a1 plus a2 plus a3. We already know a1 and a2, so we have to find a3. According to this information, we know that a3 equals to 2 times a2 plus 3 squared minus 7, which is 2 times a2, 2p squared minus 7, and we plus 3 squared minus 7 here. 2 times 2p squared minus 4 squared minus 7, and it will be 2 times 4p to the power 4 minus 16p squared plus 16, and minus 7 here, which is 8p to the power of 4 minus 32p squared plus 25. So we write down the values of a1, a2, and a3 in here, which is p minus 7 for a1 plus 2p squared minus 7 for a2, and plus 8p to the power of 4 minus 32p squared plus 25. We collect like terms, it will be 8p to the power of 4 minus 30p squared plus p plus 15. And according to this information, the summation of an where n equals to 1 to 3 equals to p plus 15. So you can equate this term to be p plus 15, and we simplify them again. So p and p here cancel, same as this term. Now we've got 8p to the power of 4 plus 30p squared equals 0. We can simplify this term. It will be 2p squared times 4p squared minus 15 equals 0. That means p squared equals 0, or 4p squared minus 15 equals 0, which means p equals to 0, or p equals to plus minus square root 15 over 4. These are the values of p. So then we have to use the values of p to find the values of a2. We can see that a2 equals to 2p squared minus 7. So when p equals to 0, a2 will be negative 7. And when p equals to plus minus square root 15 over 4, a2 will be 2 times plus minus square root 15 over 4 squared minus 7, which is 215 over 4 minus 7, which is 1/2. So the possible values of a2 are negative 7 and 1/2. Problem 9. A circle C has equation x minus k squared plus y minus 2k squared equals k plus 7, where k is a positive constant. Write down in terms of k the coordinates of the center of C and the radius of C. According to a circle equation, we know that the center has to be h and k. So the center of this circle is k and then 2k. And since this one is r squared, the radius of C will be square root k plus 7. Here is part B. Given that the point P, which has the coordinates of 2, 3, lies on C, we have to show that 5k squared minus 17k plus 6 equals 0. Here is the circle equation. So in order to show this part, we just have to substitute point P into this equation. So this is 2 minus k squared plus 3 minus 2k squared equals to k plus 7. This part will be 4 minus 4k plus k squared plus 9 minus 12k plus 4k squared equals to k plus 7. And then we can collect like terms here. So it will be 5k squared minus 16k plus 13, which is k plus 7, and then we move these two terms to the left-hand side. It will be 5k squared minus 17k plus 6 equals 0. Next, we have to find the possible values of k. From this quadratic equation, we can factorize the left-hand side to be two brackets like this. So the first one would be 5k and k here. To make it to 6, we put 2 here and 3. Both of them are negative. So then we can solve for k, which are 2 over 5 and 3. These are the possible values of k. In part C, the tangent to the circle at P intersects the x-axis at point T. So you can just draw an illustration roughly like this. And here is T. Given that k is less than 2, calculate the exact area of the triangle OPT, which is this one. First, we have to find the center of this circle. And according to this information, k has to be less than 2. And from the previous problem, we've got two values of k, which are 2 over 5 and 3. So we are going to choose k equals to 2 over 5. Then we have to find the equation of the tangent line. We already know the coordinates of this point and this point. So we have to find the gradient of this line first, then we can find the gradient of this line. So the gradient of this line from the center to P is 4 over 5 minus 3 divided by 2 over 5 minus 2, which is 11 over 8. That's the gradient of this line. And according to circle theorem, we know that these two lines are perpendicular, so we can find the gradient of the tangent line. So M tangent has to be negative 8 over 11. And we know the gradient of this line, and we know the point on the line, which is point P. So then we can find the equation of the tangent, which is y minus 3 equals to negative 8 over 11 times x minus 2. And we can rearrange this equation to be 11y plus 8x equals 49. And to find the coordinates of t, which is on the x-axis, so we substitute y equals to 0 into this equation to find t. Y will be 0, so this one will be 8x equals to 49, so the x-coordinates of t is 49 over 8. To find the area of OPT, we can use a formula of a triangle, which is 1/2 times base, could be from O to T, which is 49 over 8, and the height, which is the height of this point. Point P has the coordinates of 2, 3, so the height of this triangle is 3. Multiply by 3 here, and the answer is 147 over 16. Problem 10. Owen wants to train for 12 weeks in preparation for running a marathon. During the 12-week period, he will run every Sunday and every Wednesday. On Sunday in week 1, he will run 15 kilometers. On Sunday in week 12, he will run 37 kilometers. He considers two different 12-week training plans. In training plan A, he will increase the distance he runs each Sunday by the same amount. Calculate the distance he will run on Sunday in week 5 under training plan A. From the information, we know that the first term is 15, which is A1, and then A12 is 37. From the information in plan A, the distance will increase by the same amount. That's why we know that in this case, we have the arithmetic sequence, which is AN equals to A1 plus N minus 1 times D. We can find a common difference from A12. 37 equals to A1, which is 15 plus 11 times D. That means D will be 37 minus 15 over 11, which is 2. That's a common difference. So now we can find the distance in week 5, which is A5. So A5 will be A1 plus 4D, which is 15 plus 4 times 2. And the answer is 23 kilometers on week 5. Here is part B. In training plan B, he will increase the distance that he runs each Sunday by the same percentage. Calculate the distance he will run on Sunday in week 5 under training plan B. Give your answer in kilometers to one decimal place. We have the same information, but according to plan B, the distance will increase as a percentage. That means we have the geometric sequence, which has the formula of AN equals to A1 times R to the power of N minus 1. And we can find the common ratio, which is R, by using A12. Here is 37 equals to 15 times R to the power of 11. So R11 is 37 over 15. And to solve for R, we just have to find the 11th root of 37 over 15. That's a common ratio. We still have to find the distance in week 5, which is A5. So A5 equals to A1 times R to the power of 4, which is 15 times 11th root of 37 over 15 to the power of 4. And the answer is 20.8 kilometers for Plan B. In Part C, Owen will also run a fixed distance each Sunday over a 12-week period. Given that x is an integer, the total distance that Owen will run on Sundays and Wednesdays over the 12 weeks will not exceed 360 kilometers. Find the maximum values of x if he uses the training plans A and B. In Plan A, we can find the total distance from the arithmetic series, which is Sn equals to n over 2 times a1 plus an, when an is the last term. And since we already know the last term, so we can use this formula. So in 12 weeks, S12 will be 12 over 2 times 15 plus 37, which is 312 kilometers in total. And then to find the distance x for each week on Wednesday, it will be 360, which is the maximum distance, minus 312 divided by 12 here, which is 4. Let's move on to Plan B. We can find the total distance from the geometric series, which is this formula, a1 times 1 minus r to the power of n, divided by 1 minus r. So in this case, we have the total distance as S12, which is 15 times 1 minus 11th root of 37 over 15 to the power of 12 divided by 1 minus the 11th root of 37 over 15. And the answer is 294.185. This is S12. Then we can find the distance x, which is 360 minus 294.185 divided by 12. This is the distance for each week, which is 5.4. So the distance x has to be at most 5.4. So the maximum distance in kilometers from Plan B is 5 kilometers. That's a wrap. Thanks for watching and see you in the next video.